continue to talk about bivariate data, we're going to talk about something called a scatter plot and its association. So we're going to fill in these notes together. Scatter plots are graphs that use points to display graphical data. And they may give that to you in a table, but we're going to put it on a graph with two variables. Or again, graphs that have two different variables, it's going to be bivariate, okay, meaning two variables. Scatter plots can help determine if one variable has an effect on the other, if there are overall trends, patterns, or correlations. You'll also see this word or associations between the variables. So we're looking for, does one affect the other, how, or maybe it doesn't at all. So here is an example. Susie went to the mall and surveyed shoppers to see how many items they purchased and the total amount of money they'd spent at the mall. She created the scatter plot below. So notice that she did a really good job of labeling her axes. So our variables are number of items and total money spent. These are the two variables that she is comparing. And you can see that each dot will represent a person. And so this person bought 2 items, they spent $20. This person bought 3 items, they spent $80. This person bought 3 items and spent $140. How many shoppers did she survey? Well, that's just going to be count the dots, okay? Because each dot represents a person. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 shoppers. Does the number of items purchased seem to have an effect on the amount of money that the shopper spent? Well, let's see. This person spent $10, almost $200. This person bought 9 items and spent almost $160 and $180. So I would say yes, right? The more they buy, so the more items bought, it appears the more money was spent. Okay, this is going to be what we call a linear positive correlation or association. Okay, linear because you can see that for the most part, we are going up, right? Most of these, it's going up, so it's positive, but it's also, they kind of go on a line, right? Which is what we were talking about with y equals mx plus b. So we do actually have 3 different types of association or correlation. We have positive, negative, and no association. So let's look at the differences. 2 variables have a positive association when the variables move up. So just like, think of a positive slope, right? They're increasing from left to right. For example, as one variable increases, the other increases. Now, we can also say that as one decreases, the other decreases, because a negative divided by a negative is a positive. So this is going to be up, up, or down, down, right? 2 variables have a negative association when variables move in opposite directions, right? Meaning, as one variable increases, the other decreases, right? So one goes up, the other goes down. And you can see again, just like slope, this is the line, and the data tend to be decreasing. 2 variables have no association when the change in one variable has no effect on the second. So we can't really tell, what's going on. Are they all going up? Are they all going down? What's happening here? So this is no correlation, okay? And the other information I want you to take from this is that for the most part, these 2 are linear. The dots tend to create a line. This is non-linear, right? It's just all over the place. Here's some examples. Describe the type of association you expect to see between the following: the hours a person studies and the number of states they visited. So as the number of hours a person studies goes up, does that determine how many states they visited? No. So this is a no association or no correlation example. It's kind of like your shoe size and your hair color. They're not related. The hours a person studies and their grade on an exam. So if we study more, do we tend to get a higher grade? Hopefully. So this would be a positive association. The hours a person studies and the hours they spend watching TV. Well, if you spend a lot of hours studying, you're probably not going to have a lot of hours to spend watching TV. So as one goes up, the other goes down. This is a negative association or correlation. All right. On the back, if a straight line can be drawn to follow the overall trend, that's what I was kind of sketching before, it is a trend line. So we're kind of showing the direction of what is going on. If the points of the data are close together, the association is strong. That means that the data is really, really close to linear. And if the points in the data are widely spread out, the association is weak. It can still be linear, it's just not going to be as close to the line. So if we were to draw a trend line, which is going to be a line that's kind of like your average line, so you can think of it like here's my high line, here's my low line. So your trend line is going to kind of split the difference. And you can see this is linear, right? They are in a line pattern, and it is positive, it is going up. And the dots are super close to my trend line here. So this is going to be a strong linear positive correlation. Okay. Same thing here, and if you want, it's going to help you if you try to draw like an outside line real light on the top and the bottom, and then you've got your inside line. This is like your average. You're going to kind of split the difference of your two lighter lines, and you can see that this is also linear. It is also positive, but now the dots are not quite as tight with this trend line as this other one. So this is going to be a little bit weaker. If we drew a line to kind of pattern this kind of through the middle, we can see that this is in fact non-linear. It is positive, it is going up. Sorry about that. And they are really close to the line, so this is still strong. It's just an example of non-linear. It's not going to be a straight line, it's a curved line. Here, I kind of draw my outside lines, and so I can split the difference from my inside line. This is going to be my trend line. And I can see that this is still linear. It's kind of in a line compared to 3. It is negative because it's going down. And this is pretty strong. Those dots are pretty close to my trend line that I drew. Here, I can see it's kind of curved. It is non-linear because it is curved, but it is going down, so it's still negative. And the dots are kind of spread out, especially compared to the dots on this one. So this is going to be a weak association. This one, I can't really tell what they're doing. They're just kind of all over the place. So this is, again, non-linear. I can't draw a line. And this is going to be no correlation. And a no correlation or no association is always, always super, super weak. Because it's not even close to being a line. So here we have, again, some more bivariate data. Describe the type of association you expect to see between the following variables. A person's height and their shoe size. Well, what happens as you get taller? Your foot tends to go up. So this would be a positive correlation. We can say, as a person gets taller, their foot grows. The number of letters in a person's name and their IQ. Well, if you have a lot of letters in your name, does that mean you're super, super smart? No, not really. So this would be a no association or no correlation. We can say they are not related. If they were related, then maybe everybody would have super long names to match their super high IQ. The number of absence a student has in their GPA. So if you're absent a lot, your GPA tends to be low because you're going to have some missing work. So this is going to be an example of a negative association or a negative correlation. We can say the more you miss, the less you learn. And then this is a matching. So let's see how we do here. The temperature outside and the total gallons of gas sold at the gas station. The size of a home and the cost of the monthly utilities and the altitude of a hiker and the total oxygen. Okay, well, if the temperature goes up outside, does that mean that gasoline is being sold a lot? No, this is a no association. So this is going to be letter A on 10 because you can see it's all over the place. If the size of your home is large, the cost of your utilities tends to be more. So this is going to be a positive. And we can see that here's my positive. So number 9 is going to be B. And as your altitude goes up, the oxygen actually goes down. So this is going to be a negative correlation or association. And we can see over here, this one is going down. So number 8 is going to be A. Let us know if you have any questions. Have a great day.